All right. This week lecture 2 we're discussing on database systems. Okay. So I shall be looking at the centralized and client server systems, and then we have server system architecture. Then we have parallel system, distributed system, and the network type. Okay. Please, those of you making notes at the back, don't complain you are not hearing me. So we begin with the centralized system. What is centralized system? They are those systems that run on a single computer systems and do not interact with other computer systems. So usually your personal computer is referred to as a centralized system. It does not have any connection with other systems. That means there is not a network system. It's just a single PC. Okay. So it can also be referred to as a general purpose computer system. So, and when we talk of general purpose computer system, it's a computer system that has one to a few CPUs and a number of device controllers that are connected through a common bus that provide access to what is shared memory. Okay, so it's a single user system, just as I've said earlier. Normal PC, personal computers, or workstations. Workstations are those systems that are connected to the network system. Okay, so a desktop unit, the single users usually has only one CPU. Okay, and one or two hard disks. The OS the single users usually has only one CPU. Okay, and one or two hard disks. The OS may support only one users. Okay, so in a centralized system, the operating system may support just one users. Okay, but in some cases it may support more than one users. But in a normal circumstances, it's just one user. Then centralized system could also be referred to as what? A multi-user systems. In that case, we have more disk, we have more memory, we have multiple CPUs, and a multi-user OS, operating system that supports more than one users. Okay, so server, it serves a large number of users who are connected to the system via terminals and often called server system. Okay, just as I said, server system, of course, you cannot have server system without having a client. Okay, in that case, we may have other workstations that are connected to the server, because the clients or the workstation make a request to the server, and the server supplies or responds to the request made by each of the workstation on the settings. Okay, we see how it looks like the centralized system. We have a memory, we have CPU, we have, in this case, we have one CPU. The disk controller, we have two of them there. Then we have USB controller. USB controllers are those devices that are connected to the system via USB ports. Okay, here we have USB mouse, we have a USB keyboard, and USB printers. They are parts of USB controller. Then we have a monitor, that are connected through graphic adapter. You understand, the VGA, just like we have this VGA. Okay, you connect this system through this VGA to the monitor. Okay, then in this site also we have memory. You understand? So this memory is shared by all these devices connected. So in that case, we have what is called a shared memory. All right. Then next is a client server system. In a client server system satisfies requests generated at M client systems, whose general structure is shown below. Okay, we have, in these settings, we have 4 clients. Okay, this client system could also be referred to as a workstations. Okay, and we have one centralized servers. You understand that each of the clients makes a request, and the server responds to each of their requests. Okay, and of course, client server For you to have a client-server computer, of course, network must be what? Involved, because all these clients are connected to the server through a network. Okay, it could be a local area network, it could be a wide area network, and it could be a metropolitan area network. Okay. All right, the client server. The database functionally can be divided into back end and front end. Okay. The back end manages access structures, query evaluations and optimization, concurrency control, and the recovery. So this is the function of what? The back end. But the front end consists of the tools such as forms, reports, writers, and graphical user interface facilities. Okay. Then the interface between the front end and the back end is through the SQL, structural query language, or through an application program interface, API. Okay. So here we have SQL engine, SQL user interface, we have form interface, we have report generation tools, and we have data mining and analysis tool. Okay, they are all consist of the words the front end, and the back end, of course, you have just the SQL engine. So, and the interface between both of them is called SQL or API. Okay. So, client server system advantage of replacing a mainframe with networks or workstation or personal computer connected to a back-end server machine. Okay, these are the functions. One, a better functionality for the cost. Two, flexibility in locating resources and expanding facility. Okay, so in this client server system, we have a flexibility because we can network as many workstations as we can, or as many clients we can on the server. And also the resources, there may not be a bottleneck on the resources because each of the workstation or the clients, whatever resources they need, they just make a request to the server, and server processes the request and then responds to their request. So there's a flexibility in locating resources. Also, we have better user interface. Okay, because of what? The API, it has a better user interface, and also it's easier to maintain because if one workstation fails, so it doesn't have any effect on the other workstation, they can keep on working while you are trying to, fix the workstation. But the problem here is this: if eventually the server fails, it's going to have a devastating effect on other workstations because it's only the server that has the resources. So if the server fails, it means all other workstations will not be able to access any resources from the server. So that is one of the disadvantages. Okay. Then server system can be broadly categorized into two kinds. Number one, we have transaction servers. And number two, we have what is called the data savers. So transaction servers are those servers which are widely used in a relational database system. And of course, we have looked at SQL. Maybe we are still going to discuss more on that. Then the data server used is one that is used in the object-oriented database system. Object-oriented database system. Okay. Transaction server, also called query servers system or SQL servers systems. So in these settings, the client sends a request to the server and the transactions are executed at the server and results are shipped back to the clients. Okay, just like I send my request, I need some resources. The server receives the request. Oh, what and what resources do you need? The server gets those resources ready, process them, and ship it back to the clients. So requests are specified in SQL and communicated to the servers through a remote procedure call mechanisms. Okay, remote procedure call mechanism, RPC. So remote procedure call is just like a function call. You understand? So a call to perform a function in a program that is written on other, let's say other, we can call it it's a different program altogether. But you want that segment of program to come into the current program you have to perform a function. That is what is called function call or remote procedure call, okay? So we have two of them. We have RPC and the RMI. The RMI stands for what? Remote method invocation. It's very different. So but both of them are object-oriented. So the transactional RPC allows many RPC calls to form a transaction. So you could have more than 2 RPC calls on a particular program, and each of them are performing a different function. They are not performing the same function. Different function they are performing. Just come and do your own, perform your function, and supply the results, and the program continues. Okay. So we have also what is called Open Database Connectivity, ODBC. So it's a form of a C language program application interface, standard from what? The Microsoft for connecting to a server. So sending SQL requests and receiving results. So in other words, for a client to send a request to the server and at the same time receives a response, the process is, they make use of what is called the ODBC. You understand? To allow the request and response to the request, making a request and also getting a feedback from what? From the server. Okay, so in other words, if this application is not, of course, SQL, most SQL application usually the package come with what is called ODBC. It's just a part of the application, because the absence of this ODBC will make it very difficult for a client to make a request to a server. Okay, so it has to be properly configured. So we also have JDBC. It's also a version of the JDBC, and ODBC performs actually the same function, but JDBC is from what? Java, while ODBC is from what? C language programming. All right, transaction server process structures. So a typical transaction server consists of multiple processing, accessing data in a shared memory, okay? The server processes. This receives users' queries called users' transactions, executes them, and send results back, okay? Processes may be multi-threaded, allowing a single process to execute several user queries concurrently, okay? So the multi-threaded programming is a program that allows just a single process to do what? To perform a parallel concurrent execution of what? A query from the client. So typically, multiple multi-threading server process. We also have what is called log manager process. So all these ones, we will discuss them later on the course. So we have also what is called log writer process. So in this case, server processes simply add log record to log record buffer. Then the log writer process outputs log record to stable the storage. Of course, when we talk of a buffer, it's reside in what? In a memory, okay? And what is the function is for what? For data storage, okay? So the log writer. Excuse me, you are discussing, Abi. Who is talking among you people? Who is talking? I'm asking. Who? Who is talking? Yeah, go out, please. Go out. We also have a process monitor process. Okay. So monitors, it monitors other processes and takes recovery action if any of the other process fails. Okay. You know, process, when we talk of process here, what's the key, what do you call it? The key components of a process is what? Processor and what? And the memory. Okay. Because for each process, of course, it requires the processor because the speed of each process is what is being controlled by, or speed of any system or any request is being controlled by what? By the process and what? And memory. So, and when we look at the diagram in the maybe subsequent slides, we are going to look at the diagram. Then we'll see the components of each of the process. Okay. So the point here is that when we talk of process monitor process, it's a process that monitors other process. So it monitors other processes and takes recovery action if any of the other processes fails. Okay. Example, aborting any transaction being executed by a server process and restarting it. So this is what we have been explaining. We have user process. Yeah, we have two of them. We have ODBC from C, and we have JBDC from the Java. Then we have a buffer pool. We have a shared memory here. Then we have query. We have query plan cache. We have a log buffer. We have a log table. So this is a process monitor process. And here we have log manager process. So each of the log writer process or processes we consult what we have: log disk, we have checkpoint processes, and we have database writer processes, and we have data disk. Okay, so this is just what we try to explain the previous thing. So shared memory contains shared data, which could be in form of buffer pool, the log table, and log buffer, and catch query plan, which review if same query submitted again. All database processes can access shared memory. So to ensure that no two processes are accessing the same data structure at the same time, database system implement what is called mutual exclusion. Okay, mutual exclusion function is to do what? To prevent two processes from accessing, the same data structure. And how does it do that? It uses what is called operating system semaphore or atomic instruction, such as test and set. Okay. So to avoid overhead of inter-process communication for log request grants, each database process operates directly on the log table. Okay. So instead of sending requests to log manager process, log manager process will still used for dead log detection. Data servers. So it's used in a high-speed local area network in cases where the clients are comparable in processing power to the server. The tasks to be executed are compute intense. Okay. So in this case, the tasks, when we have a very lump of tasks that may take all these scientific tasks that may take a lot of resources to be computed. In that case, we have to make use of what is called the data servers, okay? And in this case, data are shipped to a client where processing is performed and then shipped result back to the server. So in every server, client server settings, so the basic point there is what? The client makes a request, the server receives the request, process the request, and ship back to the server. That is just the settings. So this architecture requires full back-end functionality at the client. So it's used in many object-oriented database systems. And what are the issues in these settings? Number one, page shipping versus item shipping. So it could be in form of page shipping or item shipping. We have also what is locking, then data caching and lock caching. We are going to look at each and every one of them. Okay, page shipping versus item shipping. We have smaller units of shipping. In that case, we have more messages. And what it was prefetching related items along with requested items. So in this case, we don't just ship the requested item. We have to also prefetch related item in order to go along with the requested item. So the page shipping can be thought of as a form of a prefetching. Then locking. Overhead of requesting and getting lock from server is high due to message delays. It can grant locks on a request and prefetch items with page shipping. Transaction is granted lock on whole page. So lock on a prefetch item can be P called black by the servers and returned by a client transaction if the prefetch item has not been used. So locks on the page can be escalated, so lock on item in the page when there are lock conflicts. Locks on unused items can then be returned to the server. Next is data caching. Data can be cached at clients even in between transactions, but check that data is up to date before it is used. So check can be done when requesting lock on data item. Then the lock catching. Lock can be retained by client system even in between transactions. So transaction can acquire catch lock locally without contacting servers. And the server calls back lock from client when it receives conflicting lock requests. So the client returns lock once no local transaction is using it. So similar to de-escalation, but across transaction. So you need to read the textbook very well before you can understand, because this concept is not something that's like her. So you need to read these slides with the textbook. I've given the textbook to you last week. So I don't know if your course have shared it with you. So next, we want to discuss parallel systems. Parallel system in the concept of database is just the same thing as normal parallel system. When we talk of parallel system, it means you have more than what? More than one system, and they execute, instruction simultaneously or parallelly. Okay. So parallel distributed database system consists of a multiple processors and multiple disks connected by a fast interconnected network. Of course, you cannot have parallel system without a network. There must be a connection between, because the parallel system also works with what? Client servers. Okay. It could be clients connected without centralized system. and it could be a client server. Okay, so the coarse grain parallel machine consists of a small number of powerful processors, and massively parallel or fine grain parallel machine utilizes thousands of small processors. Okay, so in other words, a parallel system could be in form of coarse, you understand, grain, or massively parallel. The coarse grain are those parallel systems that the number of systems are not as much as, they are not up to, a thousands. So it could be in hundreds, or it could be in 50s, just small number of connected system on a network. But when we talk of massively parallel, we're talking of thousands of systems connected together. Okay. Then we have two main performance measures. How do you measure the performance of the parallel system? Number one, we use throughput. Okay. Throughput is defined as what are the number of tasks that can be completed in a given time interval. Okay. So it depends. When maybe you have like 3 tasks, or you have like 10 tasks given to the parallel system to perform, to execute. Okay. Then you have to check number. Okay, how much time will it take? You understand? How much time will it take this parallel system to be able to perform the 5 tasks we have given to them? Maybe, for instance, they have spent like 2 hours. Okay. Then the 2 hours, if 5 tasks they have carried out is divided by the 2 hours, the number of time, you understand? The result you are getting is what is called the throughput. Okay. Then the next is a response time, can also be used to measure the the performance. Okay, the response time is defined as the amount of time it takes to complete a single task from the time it is submitted. Okay, so for instance, if you have 5 tasks, you submit the first task, record the number of time it takes to complete that task. You submit the second one, record, submit the third one, record, until the number of tasks you have intended to execute finishes. Then you now take the total number of the time that I've spent. So that is how to calculate the response time. Okay, next we have what is called speed up. It's another measure. So a fixed size problem executing on a small system is given to a system which is n times larger. So this speed up is measured by what? Small system elapsed time over the large system elapsed time. Okay. So the speed up is a linear if equation equals to what? The n. So n, that stands for what? The number of what? Times for a larger systems. Then another measure is what is called scale up. Increases the size of both the problem and the system. So the n time larger system used to perform n time larger job is measured by scale up, equals to small system, small problem elapsed time, then big system, big problem elapsed time. So it's just like the multiplication of small system by small problem elapsed time. The time it takes the small problem to be what? To be tackled, and also the big system multiplied by the time it takes to a big problem to go elapse. So all those, if maybe peradventure you are asked to calculate any of this, so the required variable will be provided. Okay. The scale up is linear if equation equals to what? 1. All right, so this is the graph, the linear speed up and the sublinear speed up. You have the speed and also the resources. The scale up graph here also, we have the problem size, we have TSTL. So we have what is called batch and transaction scale up. Okay, we are discussing a batch scale up. Okay, a single large job typical of most decision support queries and scientific simulations. So when we talk of batch, the job that are divided into different batches. So it uses an n-time large computers on n-time large problem. N stands for what? Number of time. The number of time large computer, and also number of times large problem. Okay, transaction scale up. Numerous small queries submitted by independent users to a shared database, typical transaction processing and time sharing system. So the end time as many users submitted requests, meaning irrespective of the number of time many users submitted requests. So the number of time as many requests to a number of time as larger database on an n time larger computer. Okay, so this will require a parallel execution. Remember, we are discussing a parallel system, so it requires parallel execution, because in any parallel system settings, execution happens simultaneously or parallelly. So depending on number of words, the number of process you have, and each of the system or each of the process will have either single or multiple disk controller. So depending on what the number of clients you have, number of clients servers you have, the settings. So what are the factors limiting the speed up and the scale up? Okay. Speed up simply means what? To increase the speed, okay, the speed of execution. And scale up means what? Expand, do you understand? Resources, okay? Increase the resources. What will be the effect when the resources are increased in terms of execution? Okay. So speed up and scale up are often sublinear due to, number one, startup cost. So cost of starting up a multiple processes may dominate computation time. So if the degree of parallelism is what is high, okay, multi-processor system to set up is not all that easy. It requires a lot of number of resources, and as a result of that, it requires a high cost. Okay, because when we talk of multi-processor, we are not talking of just a single PC with. We are talking of CPU with many processors, thousands of processors. You understand? Installed on that system. So number two is what? Interference. Okay, process is accessing shared resources. Example, system bus, disk, or lock competes with each other, thus spending time waiting on other processes rather than performing useful tasks. So in this case, there will be interference, because if you have like thousands of system making a request, you understand? So of course, there need to be some has to wait. You understand? You have to create something like a queue. You understand? You be on a queue. When your turn, when it gets to your turn, then your request will be what processed and you get your response. So while you are waiting, you waste a lot of time because that time, the time waiting could be used to do what? To do other useful work. Number 3, we have skew. Increasing the degree of parallelism increases the variance in service time of a parallelly executed task. So overall, execution time determined by what? Slowest of parallelly executing task. Next is bus. System components send data on and receive data from a single communication bus. Okay, so the communication bus is just like a network bus whereby the communication takes place. And that communication is what? Sending and receiving what? Request. So it does not scale well with increasing parallelism. So the bus in the network doesn't actually scale well. When we increase the number of what? Processors, the number of a processor on the system, so it does not scale well. Next is mesh. Mesh is also talking about the components of what? The network. So the components are arranged as a nodes. Mesh is just like a node of network in a grid, and each component is connected to an adjacent component. So communication links grow with growing number of a components, and so scales better, but may require 2 root n hops to send message to a node, or root n with a wraparound connection at edge of grid. Next is a hypercube. All this is just a structure of what? The network, structure of the network. So components are numbered in binary. Components are connected to one another if their binary representation differs in exactly 1 bit. So n components are connected to log n, other components, and can reach each other via at most log n links, which reduces communication delays. So these are the structure we are discussing. This bus, this mesh, and this hypercube. So binary database architecture consists of shared memory, shared disk, shared nothing, and hierarchical. Okay. So in shared memory, the process share a common memory. So meaning they don't have, each process does not have a dedicated memory, have a shared memory. But a shared disk, in a shared disk, process will share a common disk. But in these settings, they have their own dedicated memory. Okay. In a shared nothing, it means each processor has its own dedicated memory and also dedicated disk. They don't have anything to share with other processors on the network. Then we have hierarchical. It's just a hybrid of the this architecture. Hybrid in the sense that it could be a shared memory, shared disk and shared nothing. Could be a shared disk, share not. It could be a share nothing. So it's just a hybrid mixture of either two of these. Okay. So these are the architecture of each of them. This is share memory. Okay. We discover here that we have this is process 1, 2, 3, 4, 5. Okay. I'm talking about the A, the shared memory. We have 5 processors. We have this disk 1, 2, 3. We have just one memory control here. So this memory is being shared by this process. Okay. All right. Then we also have shared disk. This disk, 3 disks are being shared by 1, 2, 3, 4, 5 process, and each of these process, they have their own dedicated memory. That's why we have M linked to each of them. Okay. This one is shared nothing. we discover that each process has its own dedicated memory and dedicated disk control. Okay. Here we have hierarchical, is a mixture of, here we have 5 processors, they are sharing one memory here with these 3 different disk control. Here we have processor, shared memory, and disk control. So this is a hierarchy, just mixture of this. Okay, shared memory. Process and disk have access to a common memory. Okay. Typically, via a bus or through an interconnected network, that is medium of sharing the memory. Okay. So extremely efficient communication between processors. So data in shared memory can be accessed by any process without having to move it using software. Okay. So all the process on the network, they have access to the memory. Just cut your own, the one you need. I cut my own, and he cut his own. Just you have as nobody stops you. Okay. So you don't need to make any request. Just you have access to the shared memory. Take as memory as you need at any point in time. Okay. And what is the downside? What are the drawbacks in these settings? So the architecture is not scalable beyond 32 or 64 processors. So since the bus or the interconnection network becomes a bottleneck, so in these settings, you cannot have more than 64 processors. You understand? In the network. So that's just the bottleneck. So your processor should be between 32 and 64 in number. Okay. Also, widely used to lower degree of parallelism. So we'll discuss that in 4 and 8 lecture. Then the shared disk. All processors can directly access all this via an interconnected network or interconnection network, but the processors have a private memory. Okay. So each of the process has a dedicated memory. They have their own private memory that is not shareable. But those 3 disks, disk controller, they can share it. They understand? They can take as many as they have. Maybe take from the first disk, take some from the second disk, take some from the third disk. So as they want. Okay. Examples here we have. The architecture provides a degree of fault tolerance. So if a processor fails, the other processors can take over each task, since the database is precedence on the disk that are accessible from what all processor. Remember, the database application resides on what? On disk. You understand? Okay. So since it resides on disk, so the failure of processor, you understand, does not have effect on what data disk. So if any of the process fails, so other can continue the execution or the processing. So example of these settings, we have IBM Sysplex and DEC clusters. Okay, so they are part of a compact running database. Okay, I also have Oracle relational database. Okay, Oracle. So they are early commercially used users. Okay. Okay, what is the downside? Okay, the bottleneck now occurs as interconnection to this subsystem. The connection of this subsystem is a problem of this architecture. So the shared disk systems can scale to a somewhat larger number of processors, but communication between processors is slower. Okay. In this case, we are not just limited to 32 or 64. We can scale as many as we can have 1,000, we can have more than that. But in that case, the communication becomes a problem because, of course, it's going to be very slow compared when you have a lesser number of processes. So the shared memory, the shared nothing, of course, as the name applies, it means each process has its own dedicated disk and what dedicated memory. So they does not have, so each of the process has their own private You understand? Resources, disk and memory. These are the two key resources. Okay. So, example, we have a Teradata, Tandem, Oracle, Cube. Okay. Data accessed from local disk and local memory access do not pass through interconnection network, thereby minimizing interference of resource sharing. So shared nothing, multi-processors can be scaled up to thousands of processors without interference. Okay, in this case, there are no need of interference. So interference also. So main drawback here is what the cost of communication and non-locked disk access. Sending data involves software interaction at both ends. So hierarchical, just as you know, just integration of any of the shared memory, shared disk, or shared nothing. So when it's integrated, we have hierarchical. So it combines the features of the shared memory, shared disk, and shared nothing architectures. Okay. The top level is shared nothing architecture. Okay. That is the top level because each of the process has its own private memory and private disk. So each node of the system could be a shared memory system with a few processors. Alternatively, each node could be a shared disk system, and each of the system sharing set of disk could be a shared nothing system. So it reduces the complexity of programming such as system by distributed virtual memory architecture, also called non-uniform memory architecture, NUMA. Next is distributed systems. Data spread over multiple machines, also referred to as what? Sites or nodes. Okay. When you have data distributed into different machines, each of the machine is called a node in the network. Okay. Network interconnects the machine. Of course, when we have a distributed system, the first thing that comes to mind is what? The network. These systems are what? Are distributed via what? A computer network. So data shared by users on multiple machines. Okay. In a sense that it could be a client connected together without a centralized server. Okay. And it could be in form of what? A client server system, the distributed system. Here we have site A, we have site B, and we have site C, all of them connected through a communication network. Okay. So distributed database will be in form of heterogeneous distributed database or homogeneous distributed database. When we talk of homo, so in these settings, same software or schemas on all sites, and data may be partitioned among sites. Okay, same software, same schema. Schema is what? The just layout, the physical structure of what? The database. Okay. So in every site, remember the sites here. So each of the system could be refer as a what? A site. Okay. So in this case, like A and B, so we have C has like 4 disks here. So what's the homo is saying is that in each of these, we must have the same program here. You understand? The same program is still here. And at the same time, you must have the same schemas. Okay. Schema is just a layout of what? Description of what? The database. So we are coming to that maybe in the next lecture. Okay. All right. So the goal of the homogeneous distributed database is to provide a view of a single database, hiding details of what? Distribution. Okay. The details about how the data has been distributed is not known to the world, the end users. So in heterogeneous, in that case, just opposite of homogeneous, we have different programs, okay, different schemas. You understand? So on different sites. So in that case, the goal is to integrate existing database to provide useful functionality. So the difference between the local and global transaction are the local transaction accesses data in the single site, okay, at which the transaction was initiated. While in a global transaction, either accessing data in a site different from the one at which the transaction was initiated, or access data in several different sites. Okay, all right. So accessing the data in what? In distributed database, you understand, could be a local transaction or what? Global transaction. You know, when we talk of sites, it's just like a system connected to the network. A distributed system is referred as what? As a site. Okay. So when a resources, you understand, or transaction takes place on this system, maybe for instance, this system, this one and this one are connected on the as a distributed database, for instance. This site A, this site B, and this is site C. Okay. So accessing data that transaction that originated from this site. You understand? You say that local transaction, I say data in the single site at which the transaction was initiated. By this system A initiated the transaction. Okay. So when you access the data through this system, you understand, only single. You understand? It means you are performing a local transaction. The transaction could also be initiated from this system. When you access data from carry out transaction through this system, it could also be referred. But when you carry out transaction, irrespective of wherever the site, you understand that the transaction was initiated. So in that case, you have what we call global transaction. So I hope you understand the difference between local transaction and global transaction. Okay, trade-off in distributed system. We have shared data. Users at one site are able to share access data residing at some other sites. So we have autonomy. Each site is able to do what? To retain a degree of control over data stored locally. Okay. So each site, they have control, you understand, of what? The data that can be accessed by other sites. Okay. Then high system availability through redundancy. Data can be replicated at remote site, and system can function even if a site fails. Okay, so failure of a site does not prevent the function of what? Of the system. So disadvantage. What is the disadvantage? Added complexity required to ensure proper coordination among sites. So now that you don't have a server, a central control system, so coordination becomes a problem. You understand? Because each of these sites behaves as they want. Nobody controls them. Just as each of the sites, they have control of their data. They can decide that, oh, nobody can access their own data resources. You understand? So that is one of the drawbacks. So software development costs will have greater potential for bugs and increased processing overhead. Okay. What are the implementation issues? Okay, atomicity needed even for transactions that update data at multiple sites. The two phases commit protocol is used to ensure atomicity. So the basic idea is that each site executes transaction until just before commit, and they leaves final decision to a coordinator. So each site must follow the decision of coordinator. even if there is a failure while waiting for coordinator decision. So the two phases commit protocol is not always appropriate. So because other transaction models based on persistent messaging and workflows are also used. So the distributed concurrency controls and deadlock detection required. Data item may be replicated to improve data availability. So all this one, we'll discuss that if time permits us to reach at chapter 22 of the textbook we are using. So the network types in the distributed database, just like normal network types, okay, which we have discussed based on our presentation here. So we have local area network, we have a wide area network, and we have a metropolitan area network. Okay, in local area network, it's composed of processors that are distributed over small geographical areas, such as a single building or a few adjacent buildings. Okay, so the network we have in this ITC building is what is called the local area network. Okay, then we have wide area network composed of processors distributed over a large geographical area. Okay, the local wide area network, is connection between different geographical areas. Okay, that means it will be interstate connection. You understand? It will be interstate connection. It could also be international connection. That is international. So this is the local area. Wide area with a continuous connection, that is the internet, are needed for implementing distributed database systems. Okay. All right. So because wide area network, as the name applies, it's not just locally based, it's wide. And for that communication to take place in a wide area network, there is need for what's internet, for what the continuous communication. So groupware applications such as Lotus nodes can work on the wide area networks with discontinuous connections. Data is replicated. Updates are propagated to replicate periodically. Okay. And copies of data may be updated independently. And no serializable execution can cause results, and resolution is application dependent. Okay, so this lecture will end for this lecture 2, not lecture 3, sorry, it's lecture 2. So before we close, we want to start lecture 3 so that. All right, we want to look at the data model. Okay. Please, let's keep quiet. So what is data modeling? Data modeling is the process of creating a data model for the data to be stored in a database. Okay. Process of creating a data model. Okay. So remember, there are difference between data model and data modeling. Okay. Data modeling is just the process of creating a data model. Okay. So data modeling, okay, this data model is a conceptual representation of data objects, the association between different data objects, and the file. So the data modeling helps in the visual representation of data and enforces business rules. So regulating compliances and government policies on the data. Data models ensure consistency in naming convention, default values, semantics, security, while ensuring the quality of the data. Okay. Naming convention here is talking about what? The data type, defining the words, the data type, okay, the attribute name, okay, the entity name, okay. So then data model. A data model is defined as the abstract model, okay, that organizes data description, data semantics, consistency constraints of data, okay. So these are the key things that data model does. It organizes data description, that is description of data, okay. We are going to use in a database. We have the data semantics, then and also the consistency constraints, okay. What are the constraints on your database, okay? The constraints has to do with the keys, enforcing an integrity constraint like primary key, secondary key, or composite key, okay? They are the constraints. Okay, we are going to look at, discuss more on that by the time we are going to do a structured query language, okay? So data model is like an architect building plan, okay, which helps to build conceptual models and set a relationship between data items, okay? So the data model, just like, when you want to build a house, you need an architect to do what, to design how the house is going to look like. And the builder has to strictly follow the instruction in order to realize what, you understand, what the architect has what specified, okay? So in this case, it's just like, okay, I want to create a database for computer science department, okay? Then we now have to, okay, design, okay, what are the components of computer science department, okay? What are the organizational charts? The first thing you need to think of also, what is the organizational chart for the computer science department? Starting from the dean of the faculty, the head of departments, okay, the staffs. Staff are divided into academic staff and non-academic staff, okay. Non-academic staff will be divided as well as the senior staff and junior staff. Also, we have students, okay. Students could also be divided into what? Level 1, level 2, level 3, level 4 students, okay. Then students also, in their own relation also, we could have students, the course registered by the students, okay. We could have student biodata, okay. We have students in level 3, okay. What are the courses they offer? What are so all this one, you need to have the conceptual layout of this. That is what data model does before you actually design the database, okay. So why use data model? So the primary goal of using data model are, number one, and to ensure that all data objects required by the database are accurately represented, okay? To ensure that to accurately represent all the data objects required by what? The database. Number two is to do what? A data model helps design the database at the what? Conceptual, physical, and logical level, okay? Because in the data model, you don't just think of designing the database on just the conceptual level only. No, even the logical level, you understand? The design will take place during what? The data model section. So the data model structure helps to define relational tables, the primary and foreign keys, and the stored procedures, okay? In this data model also, we are also required to do what? Define or enforce the integrity constraints by defining the primary key in each of the relation. Okay, what are the relationship between this table and this table? Okay, what are the relationship between, okay, academic staff and non-academic staff? What are the relationship between the students and the academic staff or the instructor? So all these things are being captured on what? Because The failure of data model will make your database to fail completely. Okay. So why use data model? It provides a clear picture of the base data and can be used by database developers to create a physical database. Okay. It's just like a base, just like an architect, just as we have said. So using it, architect, the architecture of the building, the architect of the building, the builder can simply represent that picture as just a normal building. Okay, so the same thing, if the conceptual data model is properly designed, so any database developer will use that architect or will use that data model to do what? Design the database exactly the way it's being represented. So it's also helpful to identify missing and redundant. Okay, in database you have what is called data redundancy. Okay, in data redundancy are those data that are not always useful. Some may be used today, they may not be accessed in the next maybe 3 months or 4 months. So in those period, the data remains what? Redundancy. Okay. Though the initial creation of data model is labor and time consuming, in the long run, it makes your IT infrastructure upgrade and maintenance cheaper and faster. Of course, because when you design the model very well, properly design the model, it will save you time of, wasting time on irrelevant thing and also the cost. So then what are the types of data models? Okay. There are mainly 3 different types of data model. We have conceptual data model, we have logical data model, and we have physical data model. Okay, and each one has a specific purpose. Each of these data model has a specific purpose. So the data model are used to represent the data and how it is stored in the database and to set the relationship between data items, So we begin with a conceptual data model. Conceptual data model. What is conceptual data model? So in conceptual data model, the data model defines what the system contains. So this model is typically created by business stakeholders and data architects. The purpose is to organize, scope, and define business concepts and rules. Then in logical data model, it defines how the system should be implemented, regardless of the database management system. This model is typically created by data architects and business analysts. The purpose is to develop technical map of rules and data structure. Then the physical data model, this data model describes how the system will be implemented using a specific database management system. And this model is typically created by database administrators and developers. So the purpose is the actual implementation of the database. Okay. So the physical has to do with what? The how. The logical has to do with also how, why the conceptual has to do with what the system, okay, contains, the content, the content of what? Of the database management system, okay. So here is the structure of the model. We have the logical data model, we have the physical data model, and we have a logical data model. Okay. So in further discussion of the conceptual data model, you say that a conceptual data model is an organized view of database, concepts and their relationship. The purpose of creating a conceptual data model is to establish entities, their attributes and relationships. In this data model level, there is hardly any details available on the actual database structures. Business stakeholders and data architects typically curate a conceptual data model. Okay, so the three basic tenets of conceptual data model are entity, attributes, and relationship. Okay, what is entity? Entity is a real world thing. Okay, it's just like we gave example as a computer science department database, for instance. So entity could be students. Okay, you understand? Entity could be the staffs. You understand? The staffs in the department could serve as entity. Okay, and this staff could be academic staff and non-academic staff. They could also serve as an entity. Okay, then we have attributes. It's a characteristic of a property or property of an entity. So the attributes is what? Just the characteristic of the entity. For instance, as a student entity, what are the attributes of the student? It could be student's name, student age, the course offer, you understand? Student sex, you understand? So these are the attributes of what student entity. So the same thing is applicable when we talk of the staff entities. You understand? The relationship, dependency or association between the two entities. Okay. So academic staff entity has a relationship with student entity in a sense that academic staff, they teaches students. Okay. So what they have in common is that when we come to students course offer, you understand? So it could be CSC 313, just as we are having lecture for CS1 313 now. So students are involved in CS 313, and I'm also involved as an academic staff in CS 313. I am instructor of what? CS 313. Okay, so we have a relationship in that form. So customers and products are two entities. Customer number and name are attributes of the customer entity. So the product's name and price are attributes of what? The product entity. Okay, you see? Then sales is relationship between the customer and the product. Okay, just as I use our department so that I can have more understanding. I use CSC 313 as well as a relationship between the instructors or the academic staff and the students entities, because it establishes a relationship. So what are the characteristics of the conceptual data model? Number one, it offers organizational-wide coverage of the business concept. Number two, these type of data models are designed and developed for a business audience. The conceptual model is developed independently of hardware specification like data storage capacity, location, or software specification like database management system vendors and technology. The focus is to represent data as a user will see it in the real world. Okay, just representation of what? Representation of data as a user will see it in what? Just a real world entity. Okay, so the conceptual data model known as domain models creates a common vocabulary for all stakeholders by establishing basic concepts and scope. Basic concept and scope. logical data model. The logical data model is used to define the structure of the data elements and to set relationship between them. The logical data model adds further information to the conceptual data model elements. The advantage of using a logical data model is to provide a foundation to form the base for the physical model. However, the modeling structure remains generic. Okay. So at the data model level, no primary or secondary key is defined. At this data modeling level, you need to verify and adjust the connection details that you are set in there for the relationship. Okay, so that is in a logical data model. What are the features? Number one, the logical data model describes data needs for a single project, but could integrate with other logical data model based on the scope of the project. So it's designed and developed independently from what the database management systems. So the data attributes, we have data types with exact precision and length, okay? So when you design a logical data, so you need to specify, okay, what is the data type? In each of these attributes, what is the data type we are going to use? Okay? What is the length of the data we are going to put on the data type we are specified? Maybe for instance, we have a string data type. Okay, what length of the string? Maybe a student's name, for instance. So we need to specify the string by, assuming the largest name of the students